Now that we implemented the model code and the lifecycle code, we are almost finished. We are down to UI code and CSS. We start with the main form, which covers the list of chat elements. As is the case with all the forms in this app, we derive from form for simplicity. The main body of the form is a tabs component that allows us to switch between camera, status, and calls. Camera Kit is used to implement the camera UI, but due to a regression in the native library, this code is currently commented out. There are the 3 tab containers. We make use of them in the scrolling logic later. The main form is a singleton, as we need a way to refresh it when we are in a different form. The form itself uses a border layout to place the tabs in the center. We also save the form instance for later use. We hide the tabs. It generally means that these aren't actually tabs, they are buttons. We draw ourselves. The reason for that is the special animation we need in the title area. We add the tabs and select the second one as the default, as we don't want to open with the camera view. Instead of using the title, we use title component, which takes over the entire title area and lets us build whatever we want up there. I'll discuss it more when covering that method. The back command of the form respects the hardware back buttons in some devices and the Android native back arrow. Here we have custom behavior for the form. If we are in a tab other than the first tab, we need to return to that tab, otherwise the app is minimized. This seems to be the behavior of the native app. The calls container is a Y-scrollable container. This is simply a placeholder I placed here, a multi-button representing incoming outgoing calls, and a floating action button. The same is true for the status container. This isn't an important part of the functionality with this tutorial. You might recall that we invoke this method from the main UI to refresh the ongoing chat status. We fetch up to date data from the storage. This is an asynchronous call that returns on the EDT, so the rest of the code goes into the Lambda. We remove the old content as we'll just re-add it. We loop over the contacts, and for every new contact we create a chat multi-button with the given name. If there is a tagline defined, we set that tagline. We also use the large icon for that person. If the button is clicked, we show the chat form for this user. The chats container is the same as the other containers we saw, but it's actually fully implemented. It invokes the refresh chats container method we previously saw in the order in order to fill up the container. And the floating action button here is actually implemented by showing the new message form. Camera support is currently commented out due to a regression in the native library. However, the concept is relatively simple. We use the tab selection listener to activate the camera as we need it. The overflow menu is normally implemented in the toolbar, but since I wanted more control over the toolbar area, I chose to implement it manually in the code. I used buttons with the command UI ID and container with the command list UI ID to create this UI. I'll discuss the CSS that created this in the next lesson. I create a transparent dialog by giving it the container UI ID. I place the menu in the center. The dialog has no transition and disposed if the user taps outside of it or uses the back button. This disables the default darkening of the form when a dialog is shown. This version of the show method places the dialog with a fixed distance from the edges. We give it a small margin on the top to take the status bar into account, then use left and bottom margin to push the dialog to the top right side. This gives us a lot of flexibility and allows us to show the dialog in any way we want. This method creates the title component for the form, which is this region. The method accepts the scrollable containers in the tabs container. This allows us to track scrolling and seamlessly fold the title area. The title itself is just a label with the title UI ID. It's placed in the center of the title area border layout. If we are on iOS, we want the title to be centered. In that case, we need to use the center version of the border layout. The reason for this is that center alignment doesn't know about the full layout and would center based on available space. It would ignore the search and overflow buttons on the right when centering, since it isn't aware of other components. However, using the center alignment and placing these buttons in the east solves that problem and gives us the correct title position. Search and overflow commands are just buttons with the title and the title UI ID. We already discussed the show overflow menu method, so this should be pretty obvious. We just place the two buttons in the grid. I chose not to use a command as this might create a misalignment for this use case and wouldn't have saved on the amount of code I had to write. These are the tabs for selecting camera, chat, etc. They are just toggle buttons, which in this case are classified as radio buttons. This means only one of the radio buttons within the button group can be selected. We give them all the subtitle UI ID, which again I'll discuss in the next lesson. We use table layout to place the tabs into the UI. This allows us to explicitly determine the width of the columns. Notice that the table layout has two rows. The second row of the table contains a white line using the side title underline UI ID. This line is placed in row 1 and column 1, so it's under the chat's entry. When we move between tabs, this underline needs to animate to the new position. Here we bind the listeners to all 4 buttons, mapping to each tab. When a button is clicked, we select the appropriate tab. The next two lines implement the underline animation effect that we see when we click a button. Notice how the line animates to the right tab button. To achieve this, we remove the current white line and add it back to the toggle container in the right position. We reset the height of the title in case it was shrunk during scrolling. And we finally update the layout with an animation which performs the actual line move animation. The previous block updated the tab selection when we select a button. This block does the opposite. It updates the button selection when we swipe the tabs. It uses a tab selection listener. If the button isn't selected, then we need to update it. Again, we need to reset the title size. Next, we select the button that matches the tab. Finally, we perform the animation of moving the underline between tabs. Notice that this is almost identical to the previous animation code, only in this case it's triggered by dragging the tabs instead of the button click events. The last 2 lines in this method are the bind folding call, which we'll discuss soon, and the box layout Y, which wraps the 2 containers as one. The bind folding method implements this animation of the folding title. It's implemented by tracking pointer drag events and shrinking the title. When the pointer is released, we need to check if the title shrunk enough to minimize or not enough so it would go back to the full size. If the title area height is different from the original height, it means we are in the process of shrinking the title. In that case, we need to decide whether the process is closer to the finish line or to the start. It's less than halfway to the height of the title. We reset the preferred size of the title area. That means the title area will take up its original preferred size and grow back to full height. Otherwise, we set the title area height to 0, so it's effectively hidden. Regardless of the choice we made above, we show it using an animation. We detect the drag operation by binding a scroll listener to the 3 scrollable containers. I could have used pointer drag listeners, but they might generate too much noise that isn't applicable. I chose to make a special case for the tensile drag effect. The tensile effect is the iOS scroll behavior where a drag extends beyond the topmost part, then bounces back like a rubber band. This can cause a problem with the logic below, so I decided that any scroll position above 10 pixels should probably show the full title. Now that all of that is out of the way, we can calculate the direction of the scroll and shrink or grow the title area appropriately. If the diff is larger than 0, then the title area should grow. We're setting the preferred height to the diff plus the preferred height, but we make sure not to cross the maximum height value. We then revalidate to refresh the UI. A negative diff is practically identical with the exception of making it 0 or larger instead of using the minimum value. We use the max method, and with that the title folding is implemented. The one last method in the class is this. We use a custom toolbar that disables centered title. The centered title places the title area in the center of the UI, and it doesn't work for folding. We need to disable it for this form so the title acts correctly on iOS.